Vibration analysis. Time and frequency analysis technique. Multiple frequencies nonlinear systems. Amplitude modulation. Two or more independent frequencies can be mixed together if a machine has some form of nonlinearity or other problem. There are many forms and degrees of frequency mixing. Examples of amplitude modulation, sum and difference frequencies, pulses, and frequency modulation are discussed in the following sections. Amplitude modulation occurs when two frequencies are added together algebraically. Frequencies will not add in a machine that behaves in a linear manner. Therefore, a problem must exist before amplitude modulation can occur. There are several forms of amplitude modulation. One form is a beat. A beat occurs when the amplitudes of two frequencies are added together. Assume there are two frequencies BF 29.6 Hz and 25.6 Hz, as in Figure 27. There are similarities between a high frequency writing a low frequency and amplitude modulation. The maximum 0 to peak envelope amplitude is equal to the amplitude sum of frequency 1 add by frequency 2, as shown in this equation. 0.6 engineering units add by 0.15 engineering units, equal to 0.75 engineering units, equal to 0 to peak envelope maximum. The amplitude difference of frequency 1 minus by frequency 2 is the minimum 0 to peak envelope amplitude, as shown in this equation. 0.6 engineering units minus by 0.15 engineering units, equal to 0.45 engineering units, equal to 0 to peak envelope minimum. The time period for each cycle in the time signal is 33.9 milliseconds, which is the 29.6 Hz frequency, as shown in this equation. Time period equal to 1 divided by 29.6 Hz, equal to 0.0339 seconds. The envelope frequency, however, is not the 25.6 Hz frequency, as it was for a high frequency writing a low frequency. For amplitude modulation, the envelope frequency is the difference between the two frequencies, frequency 1 minus by frequency 2, equal to 29.6 Hz minus by 25.6 Hz, equal to 4 Hz. Figure 27 contains a complete cycle of the difference frequency of 4.0 Hz. The envelope occurs at a time period of 250 milliseconds, as shown in the equation. Time period equal to 1 divided by 4.0 Hz, equal to 0.25 seconds, equal to 250 milliseconds. Amplitude modulation is the result of a cause and effect situation, and the amount of modulation can be expressed as a percentage. The frequency spectrum identifies the percent modulation as the amplitude of the lower frequency divided by the amplitude of the higher frequency, as shown in the equation. 0.15 engineering units divided by 0.60 engineering units, equal to 0.25, or 25%. The percent modulation in the time signal is expressed as the maximum envelope amplitude or MX, where mx equal to frequency 1 add by frequency 2 equal to 0.6 add by 0.15 equal to 0.75, minus the minimum envelope amplitude or MI, where MI equal to frequency 1 minus by frequency 2 equal to 0.6 minus by 0.15 equal to 0.45. Divided by the maximum envelope amplitude or MX, plus the minimum envelope amplitude or MI, as shown on this equation. MX minus by MI divided by MX added by MI, equal to 0.75 minus by 0.45 divided by 0.75 added by 0.45, equal to 0.3 divided by 1.2, equal to 0.25, equal to 25%. Thank you.